All right. My name is Frank Pinto. I'm a senior consultant with Microsoft Consulting Services.
And my name is Alfred Ojukwu. I'm also a senior consultant out of the New York office of Microsoft Consulting Services. And today we're presenting replacing BIOS with UEFI deployment.
Before we get rolling, I need a show of hands. Last night on the way to the attendee party, was anyone just playing that song that was just playing in their head? Party rock all the way, right? Everybody on the way? Yeah.
Raise your hand.
Now this morning, those of you put your hands up that hear clanging church bells in your head. Stark contrast.
All right, so again, thanks for coming to the session. What we want to do today is give you sort of an overview of what UEFI is and how it fits into the deployment space. So we have about 75 minutes. We'll go over the content basically to help you understand what UEFI is and how it's become a BIOS replacement. I'm sure many of you have been working with this to some degree and probably will start working with it with much more degree as new technologies come out. Then we'll talk about some of the OS deployment features that are built into this and how you can actually utilize UEFI to deliver to bare metal systems. And then we'll talk a little about where Microsoft is going in terms of UEFI and the secure boot process. And again, this is a 75-minute session. There is no way we can cover everything about UEFI, but we'll do our best to cover the information that's going to help you succeed while you're out there. So again, just for a show of hands, how many people actively work with UEFI systems? And I hope everyone should be raising their hand just about now. All right, well, okay, 50%. That's all right.
About half.
So what we want to do today is, for those of you that are experts on UEFI and understand the technology, and for those of you that are just sort of being introduced to what it can do, is give you sort of a framework to focus on. We're going to start with BIOS, the history of it, give you sort of a quick overview of how that looks. We'll talk about the introduction, where UEFI came in. I believe Frank will go into that when we start going. And then we'll look at some of the common configurations that we'll see in a system that is UEFI-based. We'll do a few demos. We'll have a demo that will talk about what you'll see when you're deploying a UEFI-based system. And then we'll go into some of the secure features that are built into UEFI, as well as anti-malware. And lastly, we'll open it up for questions that you may have. So that's the flow of the conversation. Again, hopefully it's Friday. You guys are able to stay awake. No one's able to falling asleep right now. And we will be calling on you if you fall asleep. All right, so brief history of BIOS. So this is very interesting. Brief history of BIOS. Now, how many people, in 1975, BIOS was sort of introduced by Gary Kildall. And it was basically the BIOS replacement was introduced as a way to provide a way for the platform to talk to the OS. And if we look at it, what we start, in just a second, the BIOS, of course, is nothing more than a platform that is a firmware that's basically put in between the firmware and the operating system. So in 1975, it was a way to sort of introduce this solution that helped to drive the ability to have the hardware talk to the OS, and just to give you an idea of where it's located, it's on the motherboard, and it allows the initialization of the CPU to the option ROMs, and it loads the drivers, and then moves into sort of the ability to pass it off to the bootloaders and allow the system to run in the OS. Now, most of us probably know using F2 or the delete button, you can actually get to it. So depending on who you are as the silicon vendor, you may configure it differently to access the BIOS from one way or another. But for the most part, that's the basic framework of how it works. And for most of us, it's been over 30 years now, so BIOS is kind of considered a legacy solution. And we are now moving into more of, how are we going to expand what BIOS is providing us as far as the middleware within the system. Now, technically it's firmware, so I just want to make sure people are aware of where it's going. So why are we moving away from BIOS? Why are we moving into the UEFI world? So there are a number of reasons why this has become a necessity. We have the 2.2 drive limitation. So if you have drives that are, the common drives that were introduced had the 2.2 drive limitation, and with that, as we move into larger platforms, larger systems, those 3 terabyte drives no longer will be able to function on the BIOS platform. And we also start looking at 16-bit real mode, which becomes a limitation as well on the BIOS, on the systems that you have today. In addition to the fact that you have a lack of support for networking. Again, a lot of our stacks are moving towards IPv6, and we're starting to notice that that also is a necessity of what we're looking for in our systems. So many of you are also seeing a lot of limitations in option ROMs. So I think when Frank goes into some of the UEFI discussions, one of the things we'll notice is the fact that many of the vendors that are part of the UEFI are part of making that decision of how the systems are going to interact with the firmware or the components, the keyboards, the USB drives that are added into it. So with the BIOS, we see a limitation of that happening, and as well as an aging GUI. So most of us are used to the blue and white screen that you log into, you go into there, check out the firmware, you move from one screen to another. So that's also kind of going, it's kind of becoming sort of aged, and we're needing to move to a much more flexible, much more robust product that can actually allow us to move around from place to place. And lastly, a lot of our OEMs are standardizing on 64-bit. So these are some of the reasons why we're moving away from BIOS and moving towards the UEFI framework. Here's a really good example of where BIOS is sort of limited. And we talk about the fact that it's written in assembly code. And if we see here, going to UEFI, you start seeing that the C code becomes sort of the simplification of the underlying structure for UEFI, for BIOS, or the firmware. And less files, less clutter, and if you need to change things, you can move it, you can change things much easier with this framework.
Anyone here write in assembly? Anybody? Hey, wow, all right. Got 5 or 6 out there.
All right. So let's keep going here. So the BIOS programs also serve as a middle layer between the hardware and the software. And the main function of these programs is to basically convert the high-level instructions from various software packages into the low-level electrical signals that usually is interpreted by the controllers or the various hardware. So, for example, when you click on Save in Word in the application, it sends a save request to Windows, the system software, right? And then when that passes the request to a program in the BIOS, which then that correct electrical signal sends it to the disk drive itself, causing the document in memory to be written to the disk. Therefore, the BIOS is a middle layer and the interface between the hardware and software of the computer. The details are hidden behind that whole function, and so most of us won't see that. But we just want to make sure you guys kind of see that as the important piece that kind of fits into what the BIOS is. So on to the UEFI, which is probably the more exciting thing to talk about.
All right, so we are done with the old BIOS, thankfully. And we can move on to something a little bit better. UEFI is actually stands for the Unified Extensible Firmware Interface. And basically what it is a specification that defines the interface between operating systems and platform hardware. Just as simple as that. UEFI is actually designed just to go out and do a replacement of the legacy BIOS. So let's talk about the story of the UEFI. Does anybody know what year did the 64-bit platform get released? Okay, it was in 1997. The 64-bit platform was released, but current BIOS couldn't support it, so they had to come up with something to be able to make use of the 64-bit platform and hardware. Intel first Itanium workstation was released in 2000, and it came with something called EFI, which Intel had developed internally. That was version 1.02. Now, HP first released an Itanium 2 system in 2002. That could boot into Windows, Linux, FreeBSD, HPUX. This was starting to become something that was more functional and could be used across multiple operating systems and multiple versions of HP, specifically HP's hardware. Now, the UEFI forum was founded in 2005, and that's where we changed from this EFI to the UEFI. We're going to get in a little more detail about the U, but that's when we make that jump in 2005. Now, in 2005, there were approximately 1 million systems deployed with UEFI in the hardware or on the firmware. The UEFI forum is actually made up of some really small companies like AM BIOS, AMD, Megatrends, Phoenix, Microsoft Linux, Red Hat, Apple. They all come together as board of directors in this forum so that we could, as consumers, receive a simple interface, a similar interface, and not have to have any proprietary UEFI to deal with, because we all know that would be quite a nightmare as we're trying to get into deployment. So we really needed to get to that uniformity. So that's why we're going to be putting the U in UEFI, the uniform. The platform is independent, right? So UEFI is platform independent at this point. And that's what we really needed. That came out, and that was going to enable, and that will enable us to deploy over all kinds of systems. It's written in a standard modular C, which Alfred mentioned earlier. So that's a lot easier to program. It's a lot more current code, and it gives us much more flexibility. It provides not only the firmware, but boot time and the runtime services, so all in one package. And conceptually, that defines the protocols using EFI drivers and an EFI application that allows things like the OS loader. There's really just no need anymore for the proprietary implementation. So we now have unified extensible firmware interface. Okay, UEFI advantages. What are the advantages of UEFI? In addition to better interoperability, UEFI firmware provides the following. It does have a compatibility with earlier BIOS. So we have most current UEFI implementations with something called CSM. It's the compatibility support module. And we find that in the field, a good portion of companies are implementing x64 platform hardware, but they're not taking advantage of UEFI. They use this CSM mode, which is what we know as traditional BIOS. It's an emulator, is basically what's happening, and it emulates the BIOS within UEFI. So we get support for large disks. UEFI can handle hard drives bigger than 2.2 terabytes. Now, as hardware gets cheaper and cheaper, and disks get larger and larger, this is becoming kind of an issue, dealing with having to split end-user disks into multiple partitions. And do we keep that as a hidden partition, or do we allow the user to have a second data partition? With UEFI, you no longer have to worry about that. It supports a more flexible partitioning scheme. It uses something called GPT. That is the type of partition table that it uses. I think most of you, a show of hands, everybody familiar with a GPT partition? Okay, everybody, fantastic. So we have, that GPT disk allows us to make the 64-bit values and better describe partitions. The scheme also gives the maximum disk size of approximately 16.8 million terabytes and 128 partition, as opposed to 4. So it is CPU independent, which I think is a really big feature, an advantage of UEFI. When we are On BIOS-based systems, we have the PCI, or the Peripheral Component Interconnect, and add-on cards, and that includes a large ROM that can only take advantage of a very small bit of memory that's built into the system. So through the architecture of CPU-independent drivers, we're able to use AMD, and we're able to use Intel, and we're able to use all these new, fast CPUs that have been released over the years and continue to be released without having to have proprietary code depending upon the CPU that you're running in the hardware. So it's a modular design. BIOS implementations must be carefully customized for the specific use on each platform, on each motherboard. With UEFI, we don't have to do that anymore. It's modular. So we can take OEMs can take the modules, they can plug them in as needed. And it's uniform again. So with CPU independence and the uniformity and the component-based design, we're able to plug in the components that are necessary without the customization, so we can avoid some of the problems that we've had over the years dealing with the BIOS. So let's talk about, from a hardware perspective, what are some of the major benefits? Well, first of all, you get full memory access instead of that limited memory access, either 32-bit or 64-bit. You've got the CPU independence. You've got faster initialization. I think everyone's kind of heard about this. Whether you've had a chance to play with it or not, you get a much more rapid boot time. And it also supports a maximum disk size, as I said before, of about 16.8 terabytes. From a Windows perspective, you get a much more rapid boot time as well. So, as we go through boot phases, we have the BIOS initialization, and we have post, and then we have the Windows boot. You're going to see a much faster Windows boot when you implement UEFI. You get a much faster resume from Hibernate, which is one of the big complaints that we hear from our users, right? We put power management on there so that their laptops are not burning away that battery when they're not plugged in. And then when they go to Hibernate, they could sit there for several minutes. So with UEFI, a major advantage within Windows is that the hibernation is much, much faster. Windows offered support for UEFI starting in 2002. And currently, Windows is supporting the 64-bit version of Windows with UEFI. And then one other feature that I find pretty interesting is that it has a multicast boot. So you can actually boot from using multicast before Windows loads. So this could be really useful in scenarios where you might be loading your UEFI over the network if you're in a, let's say, a call center environment, and you choose to store UEFI over the network and boot that way. You can use multicast, which I think is pretty important. All right. Slide animations. Okay, here we go. So UEFI resembles basically a lightweight operating system. The computer itself boots into UEFI, it performs an arbitrary set of actions, and those actions are carried out. It triggers the loading of the operating system. So, I mean, if you look at it on the screen here, basically you're looking at a very small, very fast operating system that loads. It's very similar. UEFI spec defines the boot and runtime services, which means that we have a common protocol between all the communication, the services, the device drivers. It's designed to work across everything. It includes extensions and even an EFI shell if you need to get in there and make some changes within EFI. On top of all that is the bootloader, which executes the operating system's bootloader. And then we see, one of the terms that we use within BIOS is an option ROM. So we can see on the left-hand side there some of the option ROMs. We see the SAL, we see the SM BIOS, the ACM. These are all the pieces that are being deprecated at this point as we move into the UEFI.
So for those of you guys that are familiar with the GPT, we wanted to make sure you understood what the partition table layout looked like. And you start with the protective MBR, which, if you boot your system up and it sees that it's a GPT disk, it will work for a UEFI system. However, for other systems, you won't have that ability to rely on the configuration. So for the GPT disk, there's a specific, I want to go right into it, the UEFI partition, which is a FAT32 partition that's basically used to load the firmware, and it's dedicated. The reason why GPT is such a helpful way of managing the disk and the partitions that you have on your system is the fact that they're identified, each of the partitions are identified by GUIDs. And you also have the ability to have it backed up. You have a backup GPT available, and just the ability to kind of protect that information in a much more seamless, much more fluid way. So we want to make sure you kind of had a visual of what that looked like. So again, there are similarities between what BIOS does and what UEFI does. And every PC is preloaded with firmware and the hardware-specific code that directs the hardware responses to commands from higher-level software, as I mentioned before. So the firmware is typically embedded in non-volatile storage that's directly attached to the hardware device, like the driver execution environment. So the BCD controller itself. So here what you see is the calling the boot service, the process of the system booting up using the firmware, coming from the initialization all the way up to the exiting the boot services and passing the control over to the operating system. Again, the similarities are there. It's just the beauty of it is UEFI speeds things up so much more. It gives it sort of a much more seamless flow, and it uses, rather than using option ROMs, you start seeing the use of drivers to do a lot of the work that the option ROMs used to do, and just simplifies things in a way that allows things to move much quicker. So we're moving, we've talked about BIOS a little bit, we've given you sort of a history of where UEFI has come from and how it's developed, and kind of gave you a framework of what UEFI looks like from a holistic standpoint. So we're going to slowly move into what you see on your operating systems, on your systems that you're building for within your data centers. And here's a good example of the UEFI with CSM implementation. Again, CSM is the compatibility support module. And that is particularly for systems that haven't really fully gone over to the native UEFI format. So CSM is built into it to allow that backwards compatibility. And when you boot up, what you'll see is if it's a system that is in legacy mode or mixed mode, you'll get these options, and you'll know that it's not in the native UEFI mode. All right, so we talk about the boot method comparisons. So the difference between what you see in the legacy boot and what you would normally see in the modern boot or the boot that is used by UEFI. So most PCs today, the pre-operating system environment is basically vulnerable to a lot of attacks, and by redirecting that bootloader handoff to possible malicious loaders, which is a big problem. And these loaders would remain undetected from the operating system, and and without the secure measures or any sort of anti-malware. So a lot of these also come into play as you're redesigning what UEFI is, how it works, and how it fits into the framework of the operating system. So what we'll see is, as we move forward, as Windows 8 starts addressing this, this through the vulnerability with UEFI and secure boot. And it uses the policy present in the firmware along with certificates to ensure that only properly signed certificates are able to boot what's needed on the Windows 8. So that, again, started around in 2010 as the design for Windows 8 was coming out. There was a decision that we would go towards the UEFI framework and focus on that as sort of a way to better secure the operating system. So that by the time Windows 8 came out last year, that became sort of the basic standard of what people would actually see. So we're going to keep going here, and we're going to go into the first portion of the demo. So I'm going to turn it to you. All right.
Okay, there we go. We're live. So we're looking at MDT, and this is not an MDT session, but while we're talking about MDT, I don't know if all of you are familiar, but we do have a very special guest here today, the godfather of MDT, Mr. Stand up, please. Take a bow. Mr. Michael Niehaus. Round of applause for Mr. Niehaus. So Mr. Niehaus actually put out, or continues to put out wonderful blog posts, and he has a great blog post about UEFI. Within MDT 2012, Update 1, there's native support for UEFI deployment. So we're not going to go into the depths of UEFI deployment within MDT, but I just wanted you to get an idea of how this looks and how this works within the standard task sequence.
How many people have actually utilized that as part of their day-to-day operations? Cool. Yeah, check it out. It's a really good blog. It has a lot of information of how UEFI would be used within your deployment scenarios.
So what we're looking at here is the normal partition, right? We're at the format and partition disk area, and we're looking at what would normally be used as an installation routine, right? We have one single partition, and we put the operating system there. Now, we have, Alfred, did we already show the partition tables?
The GPT, yes.
Okay. So what we would need to do in here would be to add the separate tables that we talked about. For instance, the FAT32 partition, and if you're going to put in, say, WinRE into your system, if you want to have a system recovery partition where you can place an image of your machine so that you can do the restore out in the field if necessary. So it's very, very straightforward, and like I said, the support is built right into MDT 2012 Update 1. And this is where we make that change. It's very simple. There's nothing else that you need to be concerned about. So we'll move over. Switchbox. So now we brought it. Next, we're going to talk about Configuration Manager. So I'll switch back over here to my demo box. And we have Configuration Manager 2012 Service Pack 1, which also supports UEFI deployment. So here, I've actually gone ahead and configured the different partitions that we're talking about. You can see that we have the WinRE partition here. You can see we have the EFI partition here, the MSR, and finally there's your the remaining amount of space is used for the operating system disk. Now these steps are over here, and you can see that there's actually two steps. There is a new task sequence variable. It's called isUEFI. So what the task sequence does is ask the computer, as it does ZTI gather, if UEFI is enabled. Now this is an important piece to note. If the system is UEFI capable, but UEFI is not enabled in the BIOS, then you will receive a return from isUEFI as no. Okay, so that's a really important piece to get clear in your mind. You have to understand that while the system may be capable of UEFI, the task sequence can only tell if it's enabled or not. So we would need to make sure that we enable UEFI in the BIOS and then run the task sequence if we're trying to deploy using UEFI. Now there's actually two steps. They come standard with the task sequence, and the two steps, it will check is UEFI, and if it finds that is UEFI equals no, it's going to go ahead and perform in the same way that we're used to having Configuration Manager perform. And it will deploy the standard method using the one partition on the drive. And right here we even see the variable for the format and partition disk.
Now, what snare would I use that in? Would it bare metal or replacement?
Well, that's going to work in either scenario, Alfred. Good question. Alfred wants to know when we're going to be using that task sequence. So the task sequence itself actually does identify if it's a bare metal installation or if it's a replace implementation. Now, of course, that's really important to understand because you're not going to be able to do an upgrade. You're going to need to make sure that you extract all of that user's data. If you're in a replace scenario, move that data to somewhere else. You're going to wipe away everything that's on that drive, and you're going to install as if it's a bare machine.
Cool. So moving forward, we're going to go into a little bit more detail and come back to the discussion. So how do I know if I'm using UEFI? How do I realize that what my system's made of, whether or not UEFI is actually installed on there? So you're probably not going to know whether a particular system is booted on a BIOS, a BIOS-based or UEFI-based computer until the terms become more well-known. So for some of you that have been working with it and are familiar with it, you may have a quick way of actually going in and seeing the fact that the GUI on the firmware has been updated, and you might be running a new system. So most new systems are already running the native mode of UEFI, at least the new ones that are coming out as of late. And we start things like checking the hard drive layout. Are you using GPT? Are you using the MBR? Again, once you take a look at that layout, you start seeing, okay, this is what my partition looks like. When that system was configured with the Windows CD or with MDT, it automatically does that format for you. You don't have to tell it to do it. It does it for you as long as it detects it needs to be done. So you're going to check whether it's MBR. You can check whether it's GPT. The other thing you can do is you can also check the BCD store for the version of the winload.exe that's on there. So you might want to go to Windows System 32 winload.exe, which is basically for MBR. Or you might want to look for the Windows load.EFI. Again, the EFI is the format that's used for the UEFI systems, UEFI-based systems. And again, did we talk about when the UEFI came around in 1997? Was I sleeping on that one?
Yes, we touched on it at the beginning.
All right, cool. Just double checking. And Intel?
We talked about Intel.
I was sleeping. It's Friday. So check the BCD store. Another place you might want to check is MS-Info32. Obviously, everyone knows how to start run MS-Info32, and it'll list the values under BIOS mode. And you'll be able to find that information fairly quickly and kind of see what's going on with your system itself. And also, WinPE 4.0 uses the WPE util update boot info command. And that will also give you, give you information about the get firmware type that you'll be using. You get options like 0 for BIOS and 3 for UEFI. And this kind of gives you the PowerShell command. So there's a number of ways you can actually find out what your system's running, what mode it's in. And obviously, any one of these will work for you. There's a few others. I haven't listed them all, but these are at least a good start to understanding what's running. So this last one, it talks about the PowerShell command that you can actually utilize to find that. So get secure boot, confirm secure boot UEFI to find out what you have on there. You start seeing the options, whether or not you're running it in CSM mode, whether or not it's in secure boot mode, and the values, basically 1 or 0, means yes, I'm running it in secure boot mode, which we'll talk about in a few, or no, it's still running, but it's not in secure boot mode. So let's talk about the framework. You want to talk to this real quick?
So we talked about the 3 different, we touched on the CSM mode, actually, and we talked about the fact that CSM mode is basically a BIOS emulator within UEFI. So I just want to list out on the screen some of the features. Oh, thank you, sir. I just want to list out some of the features that you get when you use the different modes. There's the 3 different modes. So do you get enhanced boot performance with CSM? No, you don't. Are you enabled to use secure boot? No, you're not. The second mode is UEFI with CSM. This is a partial emulation mode. Now that gives you better boot performance and allows you to use secure boot. So I think that's the big, you do get some performance enhancement, but the secure boot is the real key there, allowing you to lock down that boot process. And then we move into native UEFI, which gives you much faster boot times, and still you're able to use the secure boot process.
Now, I think to this point, we've been talking just about Windows 8 and the benefits you see with that platform running either in secure, in CSM, or running in native UEFI. And as we go into secure boot, you'll start to see things start changing a little bit. So let's go move into UEFI in action. Let's talk about more of the layout. Now, Frank mentioned, Windows RE, MSR, the partitions themselves. So we start looking at the actual system partition table, and when it's one of those things that you need to be aware of on your systems, what they look like. And if you go to the Microsoft TechNet site, you'll probably see some of this information available for you. Some of it is really there for your consumption, so you understand what your disk layouts look like. We have a system partition, which is available, and it has the minimum size for that partition is usually 100 megabytes. It must be formatted using the FAT32 file format. And this partition is managed by the operating system, and it should not contain any other files, including the WinRE tools or the MSR partition.
So what we're looking at it currently is the default configuration, right?
Correct.
Okay.
Correct. And the size of an MSR is 128 megabytes. You basically add an MSR to each drive for drive management, and the MSR is basically a reserved partition that does not receive, any partition ID. So it'll be there, but it won't have partition ID as you see with the GPT grid, because it doesn't store any user data per se. It's just there to manage it. So the question we start talking about MSR again. The MSR reserves space on each disk, and it's for subsequent use by the operating system. This is the second configuration, which adds on, we talked about the Windows partition. Nothing new there. It's NTFS. It's available. And I mentioned the MSR as well. So do you want to talk about this one?
Well, so what we're looking at here is the recommended Microsoft configuration. We mentioned it, we touched on it a little bit earlier, that you can have the WinRE tools there available on the drive. Show of hands, anyone using WinRE tools in the wild? Okay, just a couple of you out there. Okay, so WinRE tools will enable you to have, just to touch on that kind of quickly, WinRE tools give you advanced boot recovery. If you run into a problem with boot, they give you boot recovery tools. It depends on which tools you'd like to include, but it also includes local password unlock. Don't worry, you can lock that down too. So you have to use a username and password to boot in WinRE. It gives you the ability to fix partitions. It gives you the ability to remove updates. It's a very, very useful tool. And every time I go out on a client engagement, I always recommend that we build in to the task sequence the deployment of the WinRE tools. Then we, of course, have something that was on the default, the 3 partitions on the default configuration, the system, the MSR, and Windows, of course. And then within Windows 8, there are some features that are built in, the automatic recovery that you can go back to a point in time if you place your recovery image right on the drive. So you can have another partition, a hidden partition. It places that image on the drive, and if a person is in the field, they don't have connectivity, maybe they can't wait for a laptop depot situation, you would have that recovery image built right into the drive. Usually, you need at least 320 megabytes of space. Typically, we recommend you give it about a gig of space.
So, real quick question. We have this configuration here. I don't know if anybody knows of any other requirements for additional partitions that might come up in a Windows 8 system.
So let's make this interesting. What is, for a $10 Best Buy card, what's another partition that you can make use of there?
I had little...
No hands. Wow, I win the Best Buy card. Okay, here we go, right there. BitLocker, there you go. We got a winner. Come up and grab after the session.
After the session.
Congratulations. Yeah, so we have BitLocker partition 2. Now, what we're looking at, again, this is the Microsoft recommended. You'll find it on TechNet. This is the Microsoft recommended partition set. But if you move into BitLocker, you'd have yet another partition. And again, the task sequence can be made to do that as well.
So one other thing I want to mention about the partition and the partition table, when you talk about Windows RE, you end up having to have a dedicated partition type that must be specified when you're actually creating your disk part. And that'll show up as you're using disk part as part of your solution. And we'll show that to you in just a second. But this is essentially the framework of what you'd see when you're doing a UEFI deployment. So if you look at there's a section here that kind of goes into the grid partition, the fact you can use the disk part to actually create the disk partition if you're doing it through some sort of tool. Here you actually would specify that Windows recovery partition, and you have to set that ID to that grid, that partition grid, because it always ends up being that grid. So something to make sure that you are paying attention to when you're using your scripts. But this is a really good script if you want to do your partitioning prior to actually converting your systems. Now, again, there is no direct way to go from MBR to GPT. You have to wipe your disk. You have to wipe your disk. So if you're doing an MDT deployment, if you're doing a configuration manager OS deployment, one of the things you need to be aware of is that USMT is your friend in a replace scenario. The USMT will ensure that your data is removed from that system before it's wiped and re-imaged based on the UEFI configuration. I think we touched on this one already, didn't we?
So we included, for your benefit, because these slides are available after the session, we included just an image so that you could see what it looks like. And this is more of a reference slide for you, but that's exactly what we saw in the demonstration earlier.
Right, and one of the things we were challenged with as we were setting up the demo environment was the fact that having to show you guys the pre-OS environment would be sort of a struggle. So the executive decision was made to hold off on being able to see that in the BIOS. But again, boot process, everyone is aware of that. When you boot your system up, it comes up, it goes through the pre-OS environment and loads the operating system. Literally, if we were to boot one of these systems up, everyone knows what it looks like. Within 10 seconds, those systems will be up. So nothing new to show here for anybody. Now, does anybody know what the standard is for Microsoft in terms of what OEM should be pushing for in terms of how quickly the systems boot? 2. Very close. What was, I heard another number over here? 2.4 seconds. Very close. Right? Unless it's changed. So there is a standard out there in terms of how quickly systems should be booting, in terms of how they go about creating the firmware and ensuring that it's compliant with the UEFI specifications set by the forum. So I'm going to skip over. So now, did you want to go through this again? Or you?
Well, what I would like to do is introduce, Alfred, if you just step out front here. Alfred is showcasing the MMS speaker shirt in the medium size. Unfortunately, they didn't have the large size, so Alfred is sporting the medium. And you can see how fit Alfred is today. What we have going on here is the same demonstration. I gave it to you earlier. We had planned to do a little bit later, but since I was already in there, I gave it to you. This is the configuration manager demonstration with the built-in UEFI in the task sequence.
Anybody interested in seeing an OS deployment using configuration manager?
Yeah.
Anyway, so the boss has said...
Score 1 for Alfred. Alfred 1, Frank 0.
All right, so we're going to keep moving forward, and we're going to get into a little bit more detail of what we, Microsoft, are doing with UEFI and some of the specifications set by the forum. So let me just paint the story. We've talked about BIOS, we've talked about UEFI, we've talked about what it looks like on a disk partition and deploying it out in the system. We've shown it to you what you need to do when you're configuring it. Now we need to talk about where Microsoft is going in terms of securing the operating system, securing the pre-OS environment, and ensuring that anything that actually accesses that system is something we know about. Not just what we're booting, but what someone else might boot onto our systems. So we've taken this initiative around Secure Boot. Now, Secure Boot was introduced as part of a firmware specification that's set by the UEFI forum. Not by Microsoft, but by the UEFI forum. And it was part of UEFI 2.2. Now, another really good question. I want to see what version of UEFI are we currently on that's been currently released that's available on systems. Does anybody know? 2.3.1 C.
Charlie.
Pretty good.
We'll take 2.3.1.
We'll take that. So, yes. So, again, with the introduction of Secure Boot, we add a little bit more security to the systems in terms of how it boots up. There's now a requirement to ensure that you have the platform keys and the key exchange keys available on systems. So it adds a protocol known as Secure Boot, which can secure the boot process by preventing the loading of the drivers of the OS that are not signed with an acceptable digital signature. So shortly after the system is powered on and before it hands it off to the OS loader, the firmware will check the signature of the firmware code that exists on the hardware peripheral. So, such as the network cards, the storage devices, or any video cards. So the device codes called option ROMs will continue the process of configuring that system. So again, if you're probably wondering what a platform key is, let me just move this. The platform key establishes a trust relationship between the platform owner and the platform firmware. The platform owner enrolls the public half of the key. So setting this variable moves the machine from a non-secure setup mode to a secure boot user mode. So it's variable if it's self-signed, but that's the first stage. So that platform key is very important. It comes from the platform vendor themselves. Next, there's a key exchange key. You see it at the next level here. So the key exchange key it's called the KEK, and this establishes a trust relationship between the operating system and the platform firmware. So Microsoft owns a KEK for the operating system and the platform firmware as well. So that's built into the system on Windows 8. You'll probably see that. So the public part of the key is then enrolled in the platform firmware. And the KEK can also contain authorized signed certificates. Now, the authorized signing databases here, you see DBs and DBXs, they authorize the signed certificates. It's known as a DB, and they have a whitelist of authorized signing certificates and digital signatures that says these systems are allowed to actually load their device or their firmware components into the system. If it does not match, if it's not available in that system, that component will not load in the system, and your machine may or may not boot.
Now, it's kind of important to mention that Secure Boot is not a Microsoft invention. Windows 8 takes advantage of Secure Boot, but Secure Boot is actually a UEFI forum specification. So there are other operating systems that can also take advantage of Secure Boot.
Yeah, so I mentioned earlier, but again, the key thing here is that you have stronger keys for encryption, the fact that you're having to do these checks along the way, ensure that information is valid, and it allows you to sort of secure the types of devices that you actually connect to your Windows systems through UEFI. So this gives you a little bit more about measured boot and how it kind of acts in addition to securing the system. So measured boot, again, allows the system to ensure that what's actually being run on the system has the right signatures, and those signatures are stored within the TPM itself. So from the time you're going from the firmware itself, for each next component, when the boot chain is loaded and executed, the previous component computes the hash of the next component on the disk. So the hash is stored in the TPM within the platform configuration register, the PCR, and that hash is, and the hash, so for example, hash boot manager then stores it in TPM itself and then passes the control to the boot manager. The boot manager then launches the bootloader, then hashes that, then launches the kernel itself. So each component has a component of it stored in the TPM and ensures that it's actually the right hash. Afterwards, once that information is logged, it can actually be reviewed and ensure that that information or those systems that actually were booted are actually who they say they are. So just another way of securing the operating system and ensuring that it does a check on the system as it moves forward. So another piece here that we wanted to cover is the ELAM, early launch anti-malware. We talk about what's going on with the system. So early on, in order to secure the system even further, there's the importance of understanding that there are things called rootkits. And again, with the BIOS, we had maybe 3, 4 different rootkits that were, and I'm sure people had other rootkits that were written. Again, this isn't a, how do you break UEFI session. It's not a, what did BIOS not give you. But this is really talking about where ELAM fits into the whole solution that Microsoft is introducing. So early launch anti-malware is a driver that's especially signed by Microsoft. And Windows starts the AM software before any third-party boot drivers are available, so that malware can no longer bypass that specification. So as it's running, it identifies any AM drivers as part of the early launch, and it uses it to sort of ensure that no one else is actually able to start that system and cause any issues.
So ELAM, another note for ELAM is that ELAM will check on a cold boot. So if you do a restart, you're not going to get the ELAM check, right? You have to have cold boot for ELAM to run through the process.
Yep, so again, the key here is that if you enable your systems to have that, you have trusted boot, you have secure boot, you'll be sort of free of worrying about the fact that something might actually try to invade the operating system before it's loaded. Now, there's a lot of information around where secure boot, where anti-malware, all these solutions sort of inhibit other non-Windows operating systems from running on the hardware that's developed for Windows. Now, again, secure boot is not a required function by every system. If you need to, you have the option to disable it. However, Microsoft's recommendation is you enable it and you ensure that each one of those components or those systems or those operating systems that you want to load on that operating system have been signed with the right digital signatures and ensure that they're actually secured on during the boot process. Did you have anything to add?
Sounded perfect.
All right. Okay, so and if anyone's visited the Windows 8 blog post that is posted on the Windows 8 team, you'll probably see the same diagram, but this shows a much more holistic picture of what's going on in terms of the platform. So we see where the UEFI starts the boot process, and it passes it over to Windows OS Loader, and also the fact that you start seeing where ELAM sort of plays into this whole component, the fact that everything is reliant on the TPM chip and sort of acting as a third or fourth party, a location where information can be stored securely and validated, all the way to the point where the user actually logs on and validates the health of the system. This is where we're going with operating systems, not just securing the OS, but securing the pre-OS environment and ensuring that that boot process happens seamlessly and quickly in a much more user-friendly environment. So the OEMs have the ability to customize their firmware to meet the needs of each of their customers and the level of certificates and policy management on that platform. And we don't mandate the control of the settings on the PC firmware or enable the secure boot from any operating system other than Windows, as I mentioned earlier. So once you get your Windows system, you will have secure boot enabled moving forward. Again, this is stance that's been taken, and you still have the option to F12, whatever, get in there and make that change if needed, if you need to change the operating system. You also have the option to, if you're interested in developing drivers, if you are familiar with writing drivers for other components that are going to be part of the system, there's an EFI shell that's available. If you go to the UEFI forum, there's a lot of information around how you can actually go about ensuring that the solutions you're writing meet the specifications that are being provided by the forum themselves.
And anyone can join, by the way. So if you're very interested, anyone can join and participate in the forum.
Question real quick?
A little louder.
It's been a while since I looked at hardware. TPM was rare in consumer devices and virtually non-existent in server devices. Much of this architecture is based on TPM. What happens when it's not there?
So, I'll just go ahead and repeat the question. You said TPM is based on this configuration, and you're saying what happens if it's not there? So TPM is usually used to store the secure information. Without the TPM chip available, it'll utilize what it needs to in terms of allowing the system to boot in either the compatibility support module, and I'm so used to seeing TPM as part of the solution. And other than the fact that it needs to write somewhere that's secure, TPM becomes sort of that key location where it actually will write. So I guess it sounds like you have specific examples to kind of bring up. So maybe we can touch on that after we get done with the session. All right. So good question there. So again, this is a typical framework of what you see on the Windows 8 platform, integrity architecture, and you'll see this going forward a lot of times. And I believe Frank touched on this earlier before.
I did. So we have, we're looking at the current Windows highlights, or the current Windows-specific UEFI highlights, the multicast deployment, and then fast boot and resume from hibernation. Now, there are future UEFI capabilities. With each release of UEFI, they're working on making UEFI better, more robust, faster, more efficient. Some of the things that they're working on are actual rootkit prevention. So while we're able to use the digital signatures and the PKI certificates and lock things down, with the rootkit prevention, we want to be able to hand information off directly into the operating system to the anti-malware that you're running so that we can start collecting information and reporting on that information based on what's happening before the OS even loads. So that's one thing. And then the other is network authentication. So right from the pre-boot environment, we'd be able to authenticate over the network. I can definitely see the value in being able to authenticate before the operating system even loads on my network, when we're dealing with, say, rogue devices.
All right, and so as we kind of move into closing out, we talked about a few things. This is more for your information when you're going back through, looking at the slides, asking yourselves, why do I care about UEFI? Why should I be focusing on it as part of understanding what my platform architecture looks like? And you start seeing the fact that you can highlight things like removing the 2 terabyte hard drive limit. You can have applications and scripts running into it. You can develop them based on the C code or anything that you can have drivers that are available to actually run. But this gives you sort of a bigger picture, fuller picture of what you should expect, or what you can communicate with management, with whoever, about the benefits of UEFI as a whole. So the question is, the conference has talked about a virtualization platform, and how does this play out in that scenario? So as of right now, UEFI is based more on the hardware platform. I know that there's discussion around how we can ensure that it's being taken advantage of on the virtualization platform. I think that's kind of where your question's headed. In other words, if you were to deploy virtual operating systems in a virtual environment, can it take advantage of the UEFI framework?
So there's no current specification from the UEFI forum on how to utilize these things in a virtual environment. But that is one of the things. If you join the forum, you can look at their minutes and the things that they talk about. And that is one topic of discussion, how they can start to implement some of these features that they have for physical in a virtual world. Really good question.
Okay, and moving forward, again, another engineering benefits as well. Some of this we talked about earlier, C language firmware, and the fact that most of this is tested. It's been documented. We know how it works, and the fact that the underlying architecture is hidden below it. I don't want to read the slide itself, but again, this is for your benefit to kind of utilize as part of your planning for a UEFI-based infrastructure for the pre-OS environment. And lastly, as we close out, we have, I know it's Friday, everybody wants to get out of here and have a good time, but here's some UEFI-related content. Again, it's interesting because we didn't have any other sessions, at least I don't remember, outside of this one that really focused on UEFI as a platform solution. So we're hoping you guys can sort of feed on this, and as we develop and continue to drive the content around UEFI, that you'll be able to kind of take advantage of this. So here's a few links that is available to you to kind of get yourself caught up on what UEFI has in store and how it's actually shaping the data center and how we look at systems today.
If this is interesting content for you, if this is something that you'd like to know more about, and maybe even get in depth in where we would do a session actually running through a real deployment live, please, when you fill out the evaluations, please put that in there in the comments so that we know that. Like Alfred mentioned, this is the only session of its type, so we're obviously there's quite a few people here. It seems that there's some interest, but if you want to see maybe a 400 level, let us know and we'll work towards presenting that next time. Tech Ed or MMS next year.
Yep. And there's another one, a measured boot. Again, the slides, you'll see most of the links will be on the slide later on. And again, it's Friday, so guys, thank you for coming to the session. I really appreciate everyone showing up today. And
thanks, everybody.
We're gonna open up for questions. You can stay around and ask the questions, or you can come up. It's up to you.
Personal favor, please fill out the evals. It makes a big difference for us. That way we know if we did a good job, bad job. I'm sure we did a great job. Thanks, everybody.